Welcome Linux enthusiast. This is the 15th episode of our Linux learning series. If you have missed any of our previous episodes, here is the playlist link. In this video, we'll be talking about service management in the Linux machine. If you are looking to upskill in Linux and get globally recognized certificates, then you can check out our DevOps course. The link is given below in the description box. Alright, so now let's start the video. Alright, so let's talk about how do you manage the services in Linux. So you must be thinking, why do we need services, and why do we need to manage those? So whatever the applications, when we talked about in the operating system, we spoke about, there is a application layer which is wrapped on top of kernel, and that's how the OS is built, right? So those application layers are nothing but the services. So when I say services, which means you can just think like any application that you're going to run on your machine will be treated as a service. So kernel understands, okay, this service is running, which means the application software is currently in the active state. If a particular service which is stopped, which means that there is no communication happening for that particular service thread to the kernel and to the hardware. So how do we manage those services? Whatever is running, how to stop it, how to start it, how to make sure whenever you boot the system, service should automatically up and running. So for that, there are utilities to achieve it. So if we talk about here, so there are two utilities that we can use. One is SYSTEMCTL. Okay. So this SYSTEMCTL, it uses the mechanisms to manage the services. So this is a utility. There is an old method also, where a majority of Unix systems basically uses it, called service. Just by the service manage commands, you can manage the services. But I would recommend using SYSTEMCTL because that has some add-ons capabilities in terms of managing the services, whatever was not there in the previous services. And maybe there is a possibility that in future service command would be deprecated. So in that case, it's good to start with the SYSTEMCTL. And then in SYSTEMCTL, there are various options you can see. You can read the manual of SYSTEMCTL, how do you manage it and how do you stop it. So for example, like, to list all the units of SYSTEMCTL, you can just add option called list-units. So this will show you, it will list out all the services which are running. So you must be thinking, what is this unit? So this unit is nothing but, you can think like a application software, a service. For example, Apache, or SSH or SFTP or Samba, anything, any services which is running will be treated as a unit. So there is a single unit, and then on top of that, you can start the unit, you can stop the unit, and you will see how do you enable the unit. So that is how it is. Now, if you look at the slides, you must be seeing the commands over here. For example, how do you check the status of a service? So there is a command SYSTEMCTL status. We will be seeing that in the demo. We'll be running it in our Ubuntu machines, and we will be verifying what is the status of a service and then how do you manage those, right? So there are commands which are listed down here, and then you must be seeing at the bottom right side to view the logs as well. So we'll be covering that logs part in the next chapter. In this chapter, we'll be only covering the SYSTEMCTL and the services managing part. So now let's go back to the demo machine, and then let's try to do some demo here. So I am currently at my Ubuntu machine, and let's try to execute some commands and to see how do you manage the services. So let's execute command SYSTEMCTL list-units --type and then service. Okay. So it has listed me all the services which are currently available or loaded on the machine. So you must be seeing here that there are a lot of services which are in the load state, which are currently active, which means that currently it is performing certain actions on the OS. It must be performing whatever the criteria, whatever the specialization of a service is, it is doing the same thing. So for example, like, CUPS is an important service which basically is running, and it performs the scheduler on top of it, and that's how it reads. And then dbus, these are the messaging services which are internally used by the kernel in order to communicate via dbus. then DNS mask you're seeing. So I'm just talking and highlighting the familiar services that we have seen so far in our series. So dmessage is there, then genome, this is nothing but the graphical desktop UI. Since we are seeing the graphical units are here, you see the graphical UI of the OS, which means that service is responsible to achieve the same, and that's how we can see, oh, the service is currently loaded and it is active running state. And if you want to see what this service does, I mean, a little brief description of a service in like single statement. So it is genome remote desktop utility. Similarly, like LVM service is running, then keyboard setup is also running. There is a service called PD Mapper, which is currently in the failed state, which means there might be some issues with this service. It is unable to start, or we have stopped it, or it can be anything. So then postfix, which is uses for the SMTP servers to set up it, email servers, then SSH is there. So you must be seeing all the services which are loaded currently in the OS, and whatever the status of the services, it could be active, it could be stopped, it could be inactive, or it must be exited. So exited means the service which is currently loaded and it is active, but there are chances that few services does not need to be active all the time, which means it does not need any running status all the time. It executes, it performs the action, whatever it is responsible for, and then after that it exits automatically, which means that, okay, let's say for example you're trying to communicate, I'm just talking about some example. Let's say you're trying to communicate certain things to the hardware, and then there is a service which is responsible for that. You hit a command in order to make sure that it fetches some output for you, and for example there is a service which is basically doing the same thing as a job under the hood. So that service gets activated, and then it performs the action and then exit again, and which means that once it has given the response back to the user, it is in the exit state. It does not need to be running all the time. When user will perform some another action after that, then only it will again start, and then automatically performs the action and then goes into the exit state. There are some systemd which is how to manage the kernel and those services. So that's how these are the list of services you are seeing here which are running. So currently it says 72 loaded units listed. So which means that in order to identify at this machine at present moment, 72 services or units are there which are in the loaded state. But that doesn't mean that all the services which are in the loaded is also active when running. It could be in the active state, it could be in active state, or it could be some other exited state as well. So this third column, it defines the description, or tells about what is this actually. So the first column, which is load, it is telling you the definition of it, that it reflects whether the unit definition was properly loaded. So let's say for example there is any unit or any service which has some corrupt files, and in that case when you try to start it up, it will not load successfully. It will be some other error you might see here, or some other indications to identify saying that the service is not properly loaded. The second column is it's trying to tell that the high level unit activation state, that is the generation of sub. So this is a substate, and what is this third substate is the low level unit activation state values depending on the unit type. So as it says, that depends on the unit type, which means whatever the type of the unit or the service would be, according to it, it will try to be in the running or exited or whatnot, right? So that's how it manages that. Now let's see how do we see the manual of SYSTEMCTL. Basically what does SYSTEMCTL does. So it's saying that controls the systemd systems and service manager. So this is nothing but a utility which is used to manage the services and behave as a service manager. So there are a lot of options. This option we have already executed, list units, to list down the units whatever is available. And so the available units are in the memories, and that's how it is able to list all the units. So you can read through this, and then it will give you some idea about what does it do, what is the services and what are the states of a service. If you want to know about any help required, so you can execute this command. Then auto mounts, whatever the auto mount options and patterns, you can just provide patterns after that. Then it will also tell you the path. So basically every service has its own path, and that's how. So when I say service, right, so if you remember in the file system hierarchies we talked about in Linux, everything is a file. So even a process, whatever the process runs, that process also stays or holds a file on the Linux machine. Okay, when I say file, which means there is an entry of the process ID in the file. That's how for services also there is a file which is responsible for that service. For example, like path, like this, this service path automatically being created. So usually in /run directories you see all the paths are loaded. So let's go to /run and then systemd. Systemd is the service manager to manage the services. So you see here, all these, whatever the service, out of memories and journals and mount and everything. So it is listed down over here, and that's how you can just read and see the files which are present currently. So see, this is the system. In this directory there are files, for example, netplan, OVS, cleanup services. So this service is nothing but, it performs certain things in order to manage the DNS and configurations of your IP addresses. If you remember, we spoke in the IP assignments and networking things is starting, right? So netplan is the application which basically runs and performs the IP addressing. So this service basically manages in order to clean up whatever the cache holds up in the previous cache, and then you have changed some parameters in that networking configuration. So this service does some sort of a thing like this. So this service is nothing but a file. If you list down and try to open this file, so it says permission denied, and let's provide the super user permission. So it will list down in the whatever it consumes inside the file. So it says it's a unit. It describes what it does. So it's basically used for switch configurations for the cleanup, and it has all the parameters and conditions. So you can tweak that as well. So this is the advantage I was talking about. So Linux is so customizable. Then you can make changes in this unit files, and then according to your own use cases you can manipulate the system and saying that, no, I want it to be like behave like this, I want it to behave like this. So that's how you can make a changes. Individual files editing is possible in Linux, and that's how you can play around with it and then make sure whatever the customization is required for your use cases, you can implement those customizations. So every service contains a file, some or the other direction and paths, right? So I was talking about /run here, and all the process IDs also. So for example, like SSH. So SSH is a service, and D is a daemon. Daemon means it defines that service. So every service is being like identified as a daemon. So a daemon which is running. So if you hear somewhere daemon, so you should think like a service in the package, and that's how whenever a service is being denoted as a daemon. So a daemon is nothing but like you can just think like a service which is running. So there is a service called SSH. So its daemon is currently running, and there is a file automatically created sshd.pid. So if you basically list down or open the file, you see the process ID 92839. So and then see, so this is the SSHD which is running on our machine. So this is a process. So this process also holds a file to identifying the process ID. So this is the process ID. So if I remove this file, some sort of a conflict will happen on that, so the information whatever you see in the ps command, it was loaded the process ID for you. This information are being read from some location. So this run is basically at the memory level. It's not at a persistent storage, it is the volatile memory storage from where it is basically running. If we stop the SSH service and then restart it, there is a chance that every time you see a different process ID. So let's try to let's go ahead with the systemctl and let's try to play how do you stop a service. So you can stop it with using command systemctl stop and SSH. Okay, it asks for the password. Okay, stopping. but its triggered unit are still active. So now let's see status. Okay, the units, triggered units are currently active, but the status is showing inactive. Okay, let's start it again. Okay. So now you see the different number being stored inside sshd.pid, and if you execute the same psau aux command to list down the processes which are running, and then you are grabbing only for ssh process. So you must be seeing here that the process ID has changed. So whenever a service gets restarted or reloaded, not reloaded, because reloaded is just while service is running, you can just reload at a real time. There is no need to be restart. But when the service gets restarted, at that time, the process ID also gets changed, and that process ID information is being stored in /run directory. Similarly, whatever you see, so /run is mainly as a volatile memory, where the information which is stored, it's for short time period. Whenever something happens on the system, some sort of actions being performed, that things changes out. So mostly if somebody ask you interview questions, also people ask where do we see all the volatile stuff, where process ID, for example. So /run is the directory, you should answer it up at the time. So similarly, other process IDs also are there. Cron is also utility we discussed. So yeah, for the services also, you can just see all service path is present in the /run majority of the times, where it stores that persistent memory, that volatile memory, and then it fetches out the service information. Now let's talk about the status. So status command that we have seen already. This tells about the status of any service, whatever we would want to see. So SYSTEMCTL status and the service name. For example, SSH, or let's say cron. So cron is also a service which is currently in the loaded state. Cron is currently working, it's active, and then this is a process ID of a cron 1792. The memory, you can see the CPU usage, CPU time, it's active. C group is something which we are not covering here, but C group is, you can think like a container environment where it is isolated to any other system environment. So it's another vast topic in Linux, what is C group. And then you can see the logs, a little bit of logs, but when we'll be talking about the detailed way of logging, we will be discussing journalctl in the next chapter. But here in this output, it is basically trying to tell you that service is currently whatever the state of a service, since when the service is active, it tells you that as well. And then information about the memory and the CPU stuff, and then a little bit of a logging saying that session closed or session open or whatever, right? So it can tell you all this information. To restart, there is a restart command. So you can say systemctl restart and then cron. So it will stop it and then it will restart it. If you again see the status, it's active back, and when it was active 3 seconds ago when we did restart. So that's how you can capture it up. After that, how do you reload the service? Basically, let's say Apache, for example, you made some changes in the configuration file, or you added some index.html further in your virtual hosting path, but you don't want Apache to be restarted all the time. See, it's not always recommended. That's for the Linux give you such privileges where you don't have to always restart the service, or restart your OS. You can just reload the configuration on the fly, and it will take immediate effect. Not like Windows or which requires a restart of a machine as well in order to apply some changes, whatever you are going to make any changes, for example reg dates or some other changes you are performing. But Linux helps you that way. It can just lively update the configuration, whatever you would want to see. So for that, you can execute command systemctl reload and then sh. Okay. Yeah. So now it has reloaded. Let's check the status. So that it says, okay, when the service was active, this is the start when the service was started. Since we have reloaded the service, we have not started the service. That's why you will not see the time change over here. But yeah, it will just reload the configuration, whatever is required. So it says at the end, you see reload ssh.service openbsd Barclay standards, secure shell service. So ssh is reloaded, some sort of a configuration changes has happened at this time. So, and if you check the time, it tells that same time, when we make the changes. So that's how you can reload the service. Now, what if you want a service to be automatically started whenever system, switches on? So you can execute command enable. So this will give you a facility where whenever the system will be restarted, it will automatically executes. Okay, so for that you need sudo privileges to enable it. So with sudo, it basically synchronize whatever the changes it. So this changes also being captured somewhere, and then from there only it is reading it up. So let's see if it contains some information. Yeah. So this script is enabled or not. So when this system will boot up, it will read this script as well and try to make sure it reads whatever the settings that you have provided while executing the command. So the settings will be stored or some changes will be there in this file. And then after that, system will automatically make sure, oh, you have already set that enable or disable, and then it will take care the effect whatever it should supposed to be. So this has a list of path which is related to the enable or disable. You can read through here. This script is called by systemctl enable disable. So whenever you execute command systemctl enable or systemctl disable, it makes changes by this script. So this script is responsible. If you remove this script, then it will not take effects whatever it should supposed to take. Given unit, it needs to call the distributions mechanisms for, so whatever it does in order to make the changes, it basically updates it and then makes it. There is a command called stat command. I think we have not discussed this, but stat command, if you want to see the metadata of a file, you can execute the stat command and you can see when the last file was accessed or modified, or when it was changed, and when the file was originated, the birth of the file, So this can give you information about input output blocks or inodes and links and so stuff. So this is also a good utility to see the metadata of any files. Okay, now let's talk about if you want to see a service is enabled or disabled. So systemctl, you can see, is enabled. It says such. So this command can help you identify the current status of enablement on SSH service, which means if you want to know that this service, whenever the system will boot up, will it automatically start or not? So this status saying enabled, which means the service will automatically being started when the system was boot up. So if you disable the service, let's say systemctl disable SSH, we have to execute this with root. So sudo. Okay. Now see, it says that it removed this and this, so this is disabling. So it makes some changes. That's how the Linux is being read from the file information and then executes it. So this executes this script that we have already seen with the options or arguments disable and second argument SSH. And now I want to see, let's say systemctl is enabled. It will say disabled because you have disabled it here. So let me re-enable it, and then we're good. Yeah, it's re-enabled back. So now the system will boot up again. It will automatically being started. Okay. Now you want to list the failed services, whatever the services has failed. So for that also you can use systemctl. and then hyphen failed command. So currently, if you remember our unit list, here when we scroll down, so PD mapper service was showing failed state, okay, and then everything was currently the loaded and active state. But you don't want to read the entire table or the data, right? You directly wants to see the failed services. So you can use option hyphen fail, and this will tell you, okay, this service is currently in the loaded state, but it is failed. It is not running currently. So this belongs to some processor related things which is unable to work. So that is okay. So if any of the service which is currently in the failed state, or you make some changes, the configuration is not properly appropriate for the service to be active, then whenever you try to start the service will not start. So that failed messages you will see in the logs that we'll be covering up in the next chapter, but the status of the failed service will be listed down by command systemctl -- failed. So this is it's a good command to see the failed services. What if you want to prevent any service to start? So there is a concept called masking. Masking means you mask the service, which means whenever you try to start the service will not start. So you can kind of block a service to be started. So for that you can use command systemctl and then mask service name, let's say such sudo. So currently the service is masked and it has created a symlink we talked about in soft link and hard link. So this masking the services. Now let's try to do something. Systemctl does or not. Yeah. So it says that failed to restart the service because this unit is currently masked. Right. It's not showing in the failed because it's still active, but it is not running. So yeah, so it's not showing up here only. If you see systemctl status as such, so it says inactive dead. It's not running. So 12 minutes ago, and it says the loaded state also it's masked, so it will not be showing up here in the unit list command. That's why I try to fetch it by search it, but it is unable to search it also because it is currently masked. So if you see there is a service, so there is a requirement, let's say use case we talk about a service which you don't want anybody to stop it. Service should be always up and running. So in that case you can mask it. You can just make the service, okay, nobody should be able to touch it, and this creates some issues, so nobody will be able to do any actions, restart or stop or start, whatever. So service is in the master state. So usually it's like an admin who wants service to be masked so they can perform actions, so that user should not touch that service. So let's unmask the service now. Systemctl unmask such sudo. Okay, now it is removed from the masking thing, and now let's check the status first. So it says loaded, but it's inactive because we did not start the service. And now let's start it. Yeah, so currently service is running. Server is listing on port 22, which is what default port SSH uses, and then started the service. Okay. Yeah, so see, this is what I was trying to tell you, that the use case of it, you don't want anybody to touch this service. Currently this service is masked but is also active, and if you list down unit service, here you can search / so here you see a different dot which is in yellow color, it defining that this is currently masked. Nobody will be able to touch it, but it is in the running state. Okay, currently it's running and nobody should be able to stop it. So that kind of a facility also Linux gives you. So this is what, all about this series is, we are talking about the features of a Linux, where you can see, you can identify, you can understand, okay, it gives you a capability to tweak the services, it gives you capability to changes the parameter of a service, it gives you facility to make some modifications or the customizations as per your ease to the Linux services. That's why we say Linux is, customizable OS. It's very reliable, and you can just make any changes what you would want. So this is kind of a good use case where service, if I try to stop it, let's say systemctl stop, and then as such, it will not let me stop. So okay, it's inactive. It is masked also. I made some changes. Let's see what has happened. Okay, it's removed actually. It should not, but we'll see changes. Let's see. What if we want to start it? Systemctl start as such. Okay, it's masked. Okay, fine. So you can stop it, but you cannot start it. What if I make changes? Let me unmask. Let's see this. Okay, it's removed. Now let's start. Okay, now let's stop. Let's check the status. So status is inactive, but it is loaded. And now what if I say mask? Okay, it's masked now. Now let's try to start it. So you cannot touch, you cannot start the service because it's in the masked state. So a use case where admin knows that there is a service, it should not start, or anybody should not be able to start it because it makes some changes, or it updates some files which admin does not want it to be updated because it changed the behavior of OS. So in that case they can mask the service, and then after that nobody will be able to start it until admin mask it. Currently I am an admin, that's why I can make all these changes, but in the real time scenarios, the users who have access to the Linux machine or any servers, you will not be having full-fledged access to the machines. You cannot play around with the services. Usually the system admin is the one who is responsible, or let's say if I talk about the DevOps admin in the companies, or who manages the, let's say, IT admin servers, who manages those servers, that admin only is able to make the changes in terms of the services, because that's how the infrastructure, the internal components or stuff of a product which is running. So they don't allow you to perform any actions on the service level. But yeah, since I am an admin and you want to play around with it, so you can make the changes. So masking, unmasking also you can do, and that's how you can play around. There is another command which basically helps to reload the daemon. So systemctl and then daemon reload. Okay. Yeah. So this can also load whatever the changes, the configurations we have done. It will basically reload the systemd. So the changes in the systemd who manages the services, if you want to reload that daemon, you can just reload via this command. Now let's review some of the things of services as well. So earlier we used to use service command where when systemctl was not there in the picture, it was not invented, or I would say it was not fully being used at the time. So service command was the one which we were using before. So sudo service sh start. So that's how the command it performs the actions. So let's say sudo service sh status. So that is how this command. So if you try to correlate the options of systemctl, so where the actions that you want to perform comes in the middle as a first argument to the command, and then service name or the unit name. But in service command, it comes actions, whatever the action you want to perform, it comes at the end as a argument number 2. But as a argument number 1, the service name, whatever it is, it comes up here. So sudo service as such status. So that's how you can use service command as well to make the same changes whatever systemctl was doing for you. But it uses, see, under the hood, it uses that same systemd libraries where it was making the changes in terms of services, because systemd is a daemon which manages those services. So see, if you want to know about systemd, you can read the manual of it. So init was the command before kernel. The first process of a kernel was init before. And systemd is also the same way. It's like with the time the evolution changes, and then they created systemd. It manages the service and do the same thing. So the process ID for the systemd is always 1. Earlier it was a init process. So in interviews also people ask sometimes, what is the first process? So you can say init also, you can say systemd also. Init is the previous versions of Linux we were using init when the bootloader was old and then stuff. But now with the newer capabilities of the systems, the first process is systemd. It does the same behavior as what init used to do. The first process of the Linux machine. You can check here also if it's listing here. No, it's not listing the first one, right? Let's see. Yeah, see, the first, it's showing init only. So that is nothing but systemd is what it is managing. So the first process is always, you can say init or you can say systemd. So in the manual also you can read. See, for compatibility with sysv, if the binary is called as init and is not the first process of the machine, and then it will execute whatever it does. So you can read through that, and that's how it manages the services. So that's how you can manage via system services command. Let's say you want to restart or you want to load, so you can use command service, then service name, and then reload. So this will also do the same thing what we were doing. Systemctl reload. Systemctl reload. So whatever this command does, the alternate is service as such reload. Okay, so that is the reloading the configurations. And after that you want to list down all the services here, so you can list down service -- status all. Okay, see, this is how it is listing you the services which are present. But the way of unit listing via systemctl has some other functionality or the capabilities we saw in the list unit command, right? So see, the changes, the UI, the representation of the information, how it is doing. So that's why systemctl is the upgraded version, you can think like, of the service command, the previous service command. So but yeah, it does also tell you that this is a service which are running or not running or whatever it is doing. So you can list down all the status, and then there might be some other options as well in the service command to list down only the active, only the inactive and failed services, like that. If we talk about the live example, let's say for example currently the Apache server is running on this local host machine that we already discussed in our previous chapters, where we were discussing about the web services or virtual hosting. Now we host a website. Now what happened, let's say I want to stop it. We want to analyze, if we stop a service, the application software functionality stops, it does not work. That's what we are trying to analyze here. Okay, now we have stopped it. Now let's see if it works. See, it's not working. It's not working because it was using Apache 2 application under the hood, and we have put up a index.html page where the page was loading as per the functionality of this Apache 2 service. But now as we have stopped this daemon, it will not work. For that you can again start it, and once you do that and refresh the page, it will start working. So that is what I meant by the service, a service which is responsible to perform any actions on the Linux machine. You can start it, you can stop it, and then you can restart it, you can reload it, or you can list down all the failed services, or you can list down all the active services, and then you can see the path where the service file belongs to and contents inside those path. You can make changes, the modifications you can do in those configuration files of the services, and then accordingly it will tweak and changes. So all these things you can just go through the manual and then see things, how do you do that, what are the other options. So you can just play around with it, whatever the option you would want to play. But here it's like, we are trying to cover up a scenario where how do you use this utility. There are multiple options to it, so you can use all the options you would want to, but it depends on the use cases, whatever you have it, and that's how basically we do that. So in terms of best practices, if we talk about this session, so the best practices is more of I would say you should start with systemctl, because in future also there is a chance that the service command will be deprecated soon from all the variety of OS, Linux OS. So systemctl has some advanced version, some other more capabilities it has to perform, and then provide the information about the service, and it can do. Service command is also an alternative until it is going through. You can just see how does it work, but it is the same thing what systemctl do, but systemctl does in a good way, good fashion, and can get the more information. You can just think like a latest command of managing the services in the Linux machine. Yeah, so that's about the services and how do you manage the services in the Linux machine.
If you want to learn Linux and get certified from IBM, click on this link given below in the description. That's a wrap for this chapter. I'll meet you in the next episode of this Linux series.